this is, we already started doing greatest common factor method, and then I forgot that I started recording. Shush. Shush. So, out of this sheet, there are 5 different ways to factor. Well, no, really only 4 different ways of factoring, and then you have a mixed one down here, which is example 5. 4 different ways of factoring. We went over the first one, so just to walk back through that one. I'm really delayed, sorry. We look at these 3 pieces and we say, what can you pull out? So look at the numbers 9, 3, and 12. You can pull out a 3. And then each one of them has at least 2 x's. So we said 3x squared is what we're pulling out. If we take that out of 9x to the 4th, we have 3x squared left over. 3x to the 3rd, if you take a 3x squared out, you're left with just 1x. And 12x squared, if we take a 3x squared out, there'll be no x's left, but 12 divided by 3 is 4. So this is the greatest common factor method. We're just going to leave that answer like that one and be done with it. Okay? Good? All right, do you guys want to practice on the back side? There's numbers 1 through 6.
God.
Wow. Numbers 1 through 6 are greatest common factor. Would you like time to do a couple?
Yeah. Why
Yes?
are there
Okay,
so
do a couple.
many?
Do a couple, because they're fast. Look at how fast they are.
How do you do 2?
Try it. Try it on your own, and then you can.
Okay, you can take out as Is that how you do it?
For like number
Could add exponents.
A,
That's what you're pulling out?
Yeah.
No.
Or is
You
it the
take one
smallest?
X, the smallest.
Yeah.
Is this right?
Yeah.
for number for number 4, if you take T out, and then there's nothing left, is it just 1?
You have to put 1. Yes, correct.
All right.
Yep. Yep. It's a short section. Do you guys need to look at number 2 together, or are we
No.
good? We're good?
That's 5
See, these are quick, right? Did you get all the way done with all 6 of them?
No. What?
Yeah.
All
All
6.
six.
You
Did you?
cheated.
All 6?
How? Shut up.
What if you can't take anything out?
You can take something out of each one. You have to go to.
Yeah, then I know.
Whoa, wait a minute. When you take it out, you don't throw it away. You take it out front.
Well, that's pretty much what you do.
It's not Jason. Come here, Jason. Okay, so we just put this one.
A 6.
6, okay, so you have.
It's the same
No,
thing.
it's not. No, it's not.
Why do you need to do that?
Because you have to. Otherwise,
Why?
they're not equivalent to each other. Okay, so what do you take out here?
P.
Okay, but if you take a P out of the P, what's left over? You just have to put something in its spot. 1, right? Because that's what has to go there. Because
Funny
if
guy,
I were
Jason.
multiplying them back through, he has to be the same as what he wrote originally. Okay. All right. Let's look at like number
I'm not
5.
even done yet.
Let's look at number 5. We're on number 5. Okay. Number 5. What are you gonna take out of those 3 pieces? 2 and M. Anything else? Okay, when you take it out, you don't throw it away. You leave it,
I do.
right? So if you take 2M out of this piece, what's left over? A is left plus. Okay. If you take 2M out of the 4MB, you have 2B left over, right? plus, and then left is C on the last one. Okay? All right, so when you take it out, you don't throw it away. But it should be like, so you can rough check yourself at the end, like 2m times A is 2ma, 2m times 2b is 4mb, 2m times c is 2mc. You should be able to check your answer at the very end, and then it should end up being the same as what it was to start with. Good? All right, let's go to the next page. Back to the front side, difference of squares. Difference of squares. We are going to solve this thing, and then we are going to graph it. This is a quadratic function.
How did you graph it?
This is a quadratic function. You are talking, and I do not want you to talk. You're wasting time.
You just take the square.
This is a quadratic function because he's x squared. And do you remember what x squareds look like when you graph them?
X squared.
Straight
It's a
line.
parabola. It's a parabola. So it's either a smiley face or a frowny face. It looks like this. Okay? One of those two things, okay? And so we're solving this thing, and this is a difference of squares. And the reason why I know that it's a difference of squares, I can take the square root of 16, and I can take the square root of 36. I can take the square root of both of those things, all right?
4 and 6.
So
4x.
when you take the square root of 16x squared, what's the square root of 16x squared?
4x.
4x. So 4x goes in the front, and 4x goes in the front. Both of those things. The square root of 16x squared is 4x, 4x. The square root of 36 is 6 and 6. And one of them is plus, and one of them is minus. Now, these ones are have a little bit more work after them, because after we get them factored down, we have to set both of them equal to 0. So 4x plus 6 equals 0, and 4x minus 6 equals 0. And then we just have to solve. So,
X equals 6.
minus 6 minus 6.
X equals 6 over 4.
4x equals negative 6. And then divide by 4. What is 6 divided by 4?
6 over 4.
Which is
1.5.
negative 1.5, or negative 3 over 2. You can leave it like that. Okay, that's what he is. All right, same thing on the other side. Let's add the 6 this time, though. So
6
4x equals positive 6, and divide by 4. What's positive 6 divided by 4?
1.5.
Positive 1.5. Okay. Now, what happens at negative 1.5 and at positive 1.5? That's where they cross over here, right? So if there's 1 and there's 2, he's touching there, and he's going to look like a parabola, something like this, right? That's what he's going to look like. That's what the solutions mean, okay? Now, on the back side, you have difference of squares. You don't necessarily have to graph them, because there's no graphs for you, but you just have to break them apart, okay? Now, let's look at the instructions. This is the section for difference of squares. Ready? There is a difference between 7, 8, and 9, and 10, 11, and 12. You see the difference?
Trinomial. Yeah.
No. These ones don't have them set equal to 0, so you can just factor them down and be done. These ones, you do have to set them equal to 0, because there is an equal 0. Okay?
So,
All right, do you want some time? Yes? Okay.
So, for the bottom ones, you just do
What?
For the bottom ones,
For the top ones, you just do the first half of what we did, because it's not set equal to 0. So you just do the parentheses. Yep. And then the bottom ones, you actually have to set them equal to 0 and solve for x. Okay? Do those.
Wait, so for this, you just take out, or be that.
Right. But wait a minute. You're just doing one piece. You gotta do both pieces. It's 11x minus 15 and 11x
Minus
15.
plus.
Right? That piece and that piece and that piece and that piece. We have two pieces, right? Right over here, we have two pieces. This one and this one. 4x minus 6 and 4x plus 6. We have both. Okay?
What's the square root of 1?
What is
Uh,
what
pi
time? What
one.
times itself gives you 1?
1.
Yeah.
X squared.
Well,
0. So that is 3, right? Right? I don't see it. Okay, we getting close?
No.
No? Okay.
Hardest part is setting the equal to 0 on all of it.
Hardest part setting it equal to 0, really? Why?
I don't know how to.
Okay, which one are you on?
11.
11. Okay, what'd you get for your 2 pieces?
5 plus negative 9x, 5 minus negative 9x.
So 5 plus 9x and 5 minus 9x. Okay, equals 0. Alright, so 5 plus 9x equals 0. Okay, what are you going to move first?
That 5.
Minus 5, minus 5. So 9x equals negative 5. Yeah? And then what?
Divide by 9.
Divide by 9, divide by 9. And x equals negative 5 over 9 because it doesn't come out nicely, so we're just going to leave it. Alright? Now, take a stab at what the other one's going to look like.
The opposite.
So what's the opposite of that?
X equals 5 over 9.
Positive 5 over 9, right? As soon as you solve one, you've got the other one. It's just the negative of it, right?
It's
Or the
also
positive,
like,
right?
what does it say the second half?
No. Okay? If you're waiting, go down to mixed review. There are 2 of them down there that are difference of squares. Which ones are they?
No.
26
Figure them out.
and 30.
26 and 30, break them down. Okay, these ones you don't have to set them equal to 0 because they're not equal to 0, right?
What are 26 and 30?
What are they?
Difference of squares?
Yeah, what we just got to doing, right? Okay? And there are also 2 of them that are greatest common factor.
No.
Yep,
Which ones are those?
yep. You figured out which ones of those can you pull something out of?
I actually have no idea. 25.
What can you pull out of 25? Sure, go for it.
What about the other one? I don't find it.
He's hiding.
I guess probably 20, 27.
27?
27? What can you pull out of 27?
X.
Yeah.
Oh, I guess. I was gonna say something like that.
Okay. So do those ones that you know how to do real quick. We'll move on to the next one. Ready for simple trinomial on the backside? These we dealt with a lot this year. How do you know he's a simple trinomial? How do you know he's a trinomial? Trinomial means what? There's 3 terms, right? That's what trinomial means. And simple means no number in front of the x squared. So I'm going to say just x squared. That's how you know it is a simple trinomial. Just x squared and 3 terms. Okay? So strategy here is very easy. What do you look for? Okay? One of them you're multiplying to get, one of you're adding to get. What are you multiplying to get?
The big one.
18. Negative
3 and 6.
Multiply to get negative 18, add to get
3.
6. Or add to get 3, I'm sorry. You said what? We gotta have x in both spots there. Okay?
Negative 6 and positive 3.
Negative
No,
3
it has to be
positive
positive.
6.
What?
Negative 3 positive 6.
Oh, yeah.
Right?
Yeah.
Because we want it to be positive 3 when we add them together, right? But then, if we set them equal to 0, that's what Jason was doing, right?
Then two.
He was already having them set equal to 0 because when you set them equal to 0, x minus 3 equals 0. You add the 3 over, so x is equal to positive 3. And if x plus 3 equals 0, you subtract this, or excuse me, if x plus 6 equals 0, you subtract the 6 and x equals negative 6. So we've got 1, 2, 3, 4, 5, 6. Put a dot there. 1, 2, 3. Put a dot there. And this parabola is looking something like this. And there he is. Okay, that is what we are solving for when we do these. Okay, that is a simple trinomial. All right, on the back side, you've got 6 of those. The top 3, you can leave just with the parentheses. The bottom 3, you have to set them equal to 0.
Are there any simple trinomials on the
There are simple trinomials on the mixed review that are also greatest common factors. So the 25 and the 27 that you broke down, those are also simple trinomials. You have to break them down as well. Okay? We'll do one of those together. Okay? So just do 1 through 6 and then we'll go down to 25, 27. What? 14? What can you multiply to get 18? And then I'm going to do a couple combinations to get 18.
And then you just leave it into break down simple trinomial.
For the top 3. The bottom 3, you set them equal. If it has an equal to, equal 0 sign, you
No,
set them
I was
equal to 0.
talking about 25 and 27.
Oh, yes. Right. Okay, and then don't forget whatever you pulled out in front for the greatest common,
Yeah,
that
okay.
needs to be a part of it also. So you'll have like 3 pieces basically. Right. Exactly.
But there's no complex trinomial?
There is
Yeah,
no complex,
28,
yeah.
29,
Okay. All right. Did you get down to 25, 27?
No, I still don't know how to do complex or simple trinomial. It's
Okay.
I remember it kind of
Do you do 16?
harder,
Actually, how do you do 18?
It's the same process every time, but it's a lot of steps. Okay. 18. Multiply to get 4, add to get 5. What are 2 things that you can multiply together to equal? 2 and 2 and 1 and 4. 1 and 4.
what do you multiply to get negative 36?
I gotta make a list. Negative 36. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Any of those work?
What do you do 16?
You're trying to add to get 9. So which one of those?
3 and 12.
3 and 12.
Negative 3 and
Negative 3, positive 12. Yep, that will work.
but then you just switch them to get the actual.
Right, exactly, yep.
What's
Yep.
16?
But you don't have to do it on that one. That one you're just doing the factoring. You don't set them equal to 0. Okay? Down 25, 27. Let's look at like, I don't know, maybe 27 here. Okay? X cubed minus 16x squared plus 64. That one I said was a greatest common factor because what could you pull out? What can you pull out of there? X, okay, and left over is x squared minus 16x plus 64. But now this guy is a simple trinomial, right? That stuff that's on the inside there. So what do you multiply together to give you 64 when you add them give you negative 16? Yeah. X minus 8 and x minus 8. But don't forget this little x off to the side over there, okay? Now you may have written this just a little bit different. Don't forget the x off to the side over there, but how can you write x minus 8 times x minus 8?
X minus 8 squared.
X minus 8 squared. So you could have written like that also. I don't care which one you do. Both of them are technically the same. But that is a simple trinomial also. 25 is that same way. After you break something down and pull something out of 25, you'll have to break him down by a simple trinomial as well.
Do that too.
Okay? Yes.
What?
Yes. Okay, that's why
But
he is
there's
mixed
but
review.
there's
That's
no
why he is
round.
mixed. That's
He's
why
splitting
you have
over
two of them
27.
together.
He moved 27, I can't see it.
Okay,
I know you
that's
do
what we're gonna
some.
do right now. Ready? We gotta do complex trinomial. Hurry, right
I'm
fast.
not ready.
Okay, let's go. Complex trinomial. 7x squared minus 22x plus 3. Okay,
Just divide.
the steps. Here's step number 1.
Multiply.
Multiply A and C. What's A? 7. C is 3. 7 times 3 is 21. Okay, now we do the same thing again. I'm going to say multiply slash add. I want to multiply to get 21, but I want to add to get negative 22. Okay, multiply to get 21, add to get negative 22. Both negatives. So 7x squared minus 21x minus 1x plus 3. So basically this negative 22x I split into two pieces. The 7x squared stays, the 3 stays, the negative 22 splits into two pieces. Okay?
What's that one?
What?
That one.
Multiply. Multiply A and C. Step number 3, after you have your 4 pieces, I'll say 4 pieces. Multiply, add 4 pieces. Okay, that's what you want to try to get. Step number 3 is factor by grouping. So I'm going to group the 4 pieces into 2 each. Okay? So I'm going to group here, and I'm going to group here, and then I pull stuff out. Okay, so I have 7x squared minus 21x. What can you pull out? 7
7.
and x. Okay, and left after you pull those out is x minus 3. Okay, out of the second piece, negative 1x plus 3. What can you pull out of there?
The negative 1.
A negative 1, because you want it to be x minus 3 so that these two pieces match each other. These two pieces that are inside of the parentheses have to match. Okay, now, almost done from there. Step number 4, I'm going to rewrite. Okay, one of my first groups and one of my second groups. I'm going to yank out the two things that are in parentheses that match each other, which are the x minus 3s. I'm going to yank him out. But then left over is what?
X.
7x minus 1. Okay, last thing. Set those guys equal to 0, and
So it would be
x equals
plus 3.
positive 3. And if I do 7x minus 1 equals 0, I add the 1. 7x equals 1 and
X
divide by
equals 1 over
7.
7.
X equals 1 over 7. There he is.
Does it look like I was listening? No.
So 3, 1, 2, 3. 3 is over here. 1/7 is here. There he is. Okay, there's your complex trinomials. Okay, we'll skip example 5 because that's just a mixed review one. All right, good.
Wait, so
There's the process that you need
Can you
for
go to-
example 4.
the mixed review. Which one's the simple triangle?
The same, the 25 and 27, the
How is
same ones you did
25
greatest
one?
common factor with. If you pull a
Time?
4 out, nope. If you pull a 4 out,
Oh,
you're just left with x squared plus
Okay.
5x plus 6, right? Then that is a simple trinomial. So there can go. But also make sure you have a 4 out in front also.
Why do you need the 4 in front?
So you get to have 4 and x plus 2 and x plus 3. Like that. Okay? That's the way it's gotta be. What? What do you mean? Because 7 times 3. You take A times C and you get 21.
How do you do
And you look
16?
for numbers that you can multiply to get 21 that, but when you add them, give you 22 in the middle. And that is 21 and 1. Okay? Alright, so follow those steps to do those 6. Follow those steps to do those 6. Okay? Alright, that's all.